Alright guys, welcome to Algebra 2. This video is for homework set 5.2. So let's start. Question 1 is basically asking whether the function given in the table is an exponential function or not. If the ratio of any two consecutive terms is same, then you have an exponential function, meaning you're going from here to here. How can you go from here to from left to right? Times 3 again, times 3 again. So if it's multiplying by a number, you could also multiplying by a fraction. It's still exponential, right? As long as you're multiplying by the same number over and over, it's exponential, because it's geometric as well. Geometric sequences are exponential. James bought a used car for $20,000, which decreased in value by an annual rate of 3.82%. Now, the key thing to realize is that it decreased over time, right? Over a year. Annual means 1 year, over 1 year. Write an expression that models the scenario. Well, if James bought a used car for $20,000, that's its initial value, 20,000. It decreased, so the formula suggests 1 minus r. The r is this, but in decimal. So 3.82% in decimal is 0.0382. So this is 1 minus 0.0382 to the power of y. Y represents years here, right? So if you plug in 1, it's going to happen, one time. So you can simplify this to get 20,000, 0.9618 to the power of y. That is your answer. James bought a used car for $20,000, blah blah blah. But now they want us to write that in terms of months, right? This was in terms of years. That's why there's a y there. But what if they want you to write them in terms of months? Well, there are 12 months in a year. So your equation still remains the same. 20,000 times 0.9618. But now, how many months will it take for it to happen one time? It's going to take 12 months, because of 12 months in 1 year. So you must divide the exponent by 12. M over 12. That's it. And you're done. Alright, next question. Which of the following is true about the function g of x equals -6 1/5 power of x? Select all that apply. This 1/5 means it's an exponential decay, right? If it's less than 1, it's a decay. So this -6 has nothing to do with that. Just ignore that, okay? Whatever that is, ignore it, okay? The only two things that's going to matter is this 1/5 and then whatever, right? Now -6 1/5 to the power of x. Then they're saying this: the graph passes through -6, 0. That is not possible. You can never get a 0 out of it, right? Unless you're adding or subtracting. If you're shifting a graph left or down, that's when up or down. If you shift your graph up or down, that means your asymptote moves. But if you're not shifting it up or down, then you will never get y equals 0. So that's false. It's not growth either, because it's less than 1. 1/5 is less than 1. The graph has an asymptote at y equals 0. It does have an asymptote at y equals 0. Well, how do I know? Well, it's -6 1/5 to the power of x. Now, isn't this plus 0? If there should be like a graph shifting, this decides whether a graph shifts up or down. If there is no number here, it's 0. That means it has not been shifted up or down yet. So the asymptote is 0. But what if it's -6 1/5 x plus 2? Then your asymptote is at y equals 2, because now the graph has been shifted up to. But that's what if. That's a different question, okay? Alright, question 5. Complete the following table and sketch a graph of f of x equals 3 times 2 to the power of x. Label at least 3 points on the graph, including the y-intercept. First of all, let's figure out the horizontal asymptote. So horizontal asymptote is the graph has not shifted up or down because it's not being added or subtracted by any number yet. So the horizontal asymptote is still at 0. Now they want you to figure out let's just plug in the points, right? So plug in -2, you get 3/4. Plug in -1, you get 3/2. Then you would get 3. Then you would get 6, and then you would get 12. Right? Now let's graph it. Okay. Now this is a growth. I mean, I just plugged in this values for x and just got the answer, right? Okay. Now all I'm doing now is creating like a shape, right? Since I know that this is exponential growth, because it's greater than 1, it's shaped like this. If it's decay, it's shaped like that. But since it's growth, it's gonna go something like that. Now let's label some points. Let's label this point right here. It's 0, 1. I mean 0, 3 I meant, because it's 3. Nah, you can get a point for this video, huh? Look at that, you can get donuts. Okay, 1. The y value when x is 1, it's 6. So this is 1, 6, and then 2, 12. Let's just say that. Let's label points. Doesn't matter. Okay. State the domain and range. Domain. My graph is going left forever, so it's -infinity, positive infinity, because it's also going right forever. Now range is, will my graph ever touch this asymptote? No. So you will have 0, infinity. Next page. The population of bees is increasing exponentially. The 2 points on the graph shows the initial value and its value 2 weeks after. Express the population as a function of time w in weeks after the purchase. So let's take a look. From 0 to 2, you have 2 to 18, 2, 18. So could you not say that it's 2, something, 18, right? Because the second term is 18, the 0 term is 2. How do we figure out the growth factor? Well, what you can do is this. So 18, so 2 and 18, right? What is the ratio? Well, it's 9. The initial value is 2, right? Over, this is in terms of weeks. How long did it take? What is the change in x? It's from 0 to 2, so it's w over 2. Now this 2 is basically the square root, so it's 2 square root of 9 to the power of w, which is 2 times 3 to the power of w. That's in weeks. Now they want you to write that expression in terms of days. 12 days. So 2, 3, that's 3. How many days are in a week? 7, so it's d over 7. Now this, you simply plug in 12 for d, and that is your answer. That's an expression. That's an answer. Alright, next page. Next question and answer. Which equation here matches to the graph shown below? Well, as I can see, my asymptote is at 4. That means my graph was shifted up 4. Now that eliminates this question, and that eliminates this for sure. Now it's either this or either this. Which one is it? So if I was shifted up 4, that means I can shift it down 4 to get my real values. Here's what I mean. 0, 7, if shifted down, becomes 0, 3. 2, 16 becomes 2, 12. The growth factor is 3 to 12 is 4, x over 2, right? And that square root of 4 is 2 to the power of x, so it's b. Or you could simply plug it in. Instead of doing all this work, just plug it in, okay? For example, if I plug in 0, I should get 7, okay? If I plug in 0, 2 to the power of 0 is 1. 1 times 3 is 3, 3 plus 4 is 7. If you plug in here, 3 to the power of 0 is 1, but 2 plus 4 is 6, so that eliminates this. Okay? Plug in a point if that helps you. Question 8. Let function P represents the population in thousands of a colony of insects D days after first being measured. So, there were 1,030 insects when the colony was first counted. That's false. Why? Then they're talking about the initial value. The initial value is whatever it's here in terms of thousands, so it should not be that, it should be whatever that is, right? Like 10,000 or something, whatever that is, I don't know, okay. Or 1,000 or something, whatever, okay. But it should not be 1030 because it's after the first time it was counted, right? So after 1 day, that will be the population, 1030, not on the first count, but after the first day. 1 week after the colony was first counted, there were 10,300 insects. So you plug in 7, but that's not true either. If you plug in 7, you're not getting 10,300. The growth factor per day is 1.03, which makes sense because it is the growth factor is 1.03 per day. That's why. So C is true. The growth factor per week is 1.03 times 7. No. The growth factor per week is 1.03 to the power of 7, not times 7. The growth factor per hour is 1.03 to the power 1.03 to the power of 1 over 24, which makes sense. Here is why. 1.03 is in terms of days. To get in terms of hours, how many hours are in a day? 24. So it's h over 24. So or 1 over 24 since it's per hour. So E is true. The growth rate per day is 1.03. No, that's a growth factor, not rate. To get the rate, you do subtract 1 and times 100. So 0.03 times 100 is 3, so G is true. It is 3%. Scientists measure a bacteria population to find that it is 40,000. I mean, assume that these are all 40,000, okay? 40,000. 12 days later, they find that the population has doubled. That means the initial value is 40,000. The rate of change is 2. How long did it take for it to become double? 12. So it's 12 days, so it's D over 12. So it's B. That's it. That's the end of the video. If you have a question, I guess it's too late to ask.